everybody. Welcome. I'm glad you guys decided to come talk about Alexa today with me. Just to set some expectations, I'm going to give a short talk, maybe 10 minutes, about some of the fundamentals about what it means to build applications for voice and how we're going to do all that stuff. And then I'm actually going to jump into our web-based developer console, and I'm going to show you how all these pieces work and the choices you kind of make as you go along the way. We'll spend some time in code, and then at the end, if we still have time, I would love to show you how I can do all of the things that I show you in the web-based interface just using something like VS Code locally. So I can do all of my local debugging, I can do everything in an IDE. So as I show you guys the web console, which is, I think it's far more visually intuitive about what's going on. I don't want anyone to think for a minute that like, oh, I have to build stuff on the web. Like, no, you can do everything locally that I'm going to show you today. But first, I guess I should probably start with an introduction. So I like ridiculous pictures of myself. So there's one for you, I think. Maybe, if anything wants to work today. There we go. There we go. So my name is Jeff Blankenburg. I've been at Amazon about 6 years, just about the same time Alexa has been out. And I spend all of my time working with and talking with folks like you. So we run weekly office hours, which is a live stream where people come and ask us questions. We have an entire Slack community, which I'll talk about at the end, doing lots and lots of things to help developers understand how to build voice applications for their businesses, for themselves, side projects, whatever. And as you can see, you can find me literally everywhere as @Jeff Blankenburg. So if you have any questions, if you want to reach out to me, people always say, oh, let me get your email address. My inbox is a disaster. You don't want to be in there. But my Twitter DMs, everything else pretty much that you see there, those are all responded to. They've been read. I'm chatting with people on most of those platforms. So if you do have questions or you want to reach out, find a social network that works best for you and reach out to me. And I'd be happy to answer your questions anytime after this presentation. So the first thing that I always have to answer is, what is an Alexa skill? What does that really mean? We use the word skill rather than app because as we think about this big AI that is Alexa, we think of all of the things that you and I can build as the skills that enhance what that experience can be like for our customers. And so there are lots and lots of examples of skills. In fact, I have a whole bunch of them here. There are lots of companies that have built really interesting experiences, from Starbucks, Domino's Pizza, all sorts of things. And they allow their customers to order food or interact or get the weather or whatever their business happens to do just by asking for it in their kitchen or their bedroom or wherever. But the fundamentals behind building for voice is somewhat different than most of the other kinds of applications that we build. And so I like to spend a little bit of time talking about this somewhat ancient device, the DVD player. For a couple of questions before we get too deep into this. How many people here have ever built a chatbot or a voice application of any kind? A couple of you, okay. And then my second question is, how many of you still have a working DVD player in your house? Also a couple of you, okay. The reason I like to use this analogy is because everybody has seen and interacted with a DVD player, and so it's a really good example of how we think about a lot of the things that we do with voice. So if you think about a DVD player today, you have a few buttons on the front. You can see them. There's a play, there's a stop, there's an eject button. And if you wanted to voice activate this DVD player, the first thing you would do is sit down and say, okay, I want to make sure that when someone says play, that I do whatever the play button does, right? I send the same signal into the device. But play isn't the only thing they could say, right? They could say, it's showtime, or something more specific like play Star Wars, right? And now they didn't just say play, but they said play a very specific movie. And for those of you that can remember way back and had enough money at the time, there used to be carousel DVD players where you could actually have 50 or 70 different movies ready and queued up. Thinking back, it was like the early days of streaming, right? I had my own little NAS just sitting right there holding all those discs. Anyway, as we think about this DVD player, we think about what a user might say to trigger these individual buttons. So as I like to use this as an example because this is what we refer to as an intent. So in the voice world, in chatbot world, we think about things as intents. What is the user intending to do? What are they trying to accomplish by saying whatever it is they're saying? And these intents are the things that we're going to build here in just a minute. We'll build a little skill that has some of these intents built in. And as we have these intents, we want to map them to the things that our device can actually do. So on the DVD player, we have that play button, we have stop button, we have eject button. We probably have 30 other buttons on our remote control, right? Fast forward, rewind, pause, all of those kinds of things. All of those can be intense. And each one of those is kind of a standalone function that does something. But what we need to do is be able to map whatever the user says to those specific intents. So we provide a bunch of machine learning data to the Alexa engine to say, hey, when someone says play or it's showtime or the name of a movie, you should play using the information that you have. If they provide the name of a movie, you should play, but also play that movie that they've specified. So I like a little architecture diagram, so we'll get into that. Now that we understand what intents are, I guess I should also take one step back. If you think about that DVD player, one of the things that you would not expect a DVD player to do is tell you what your bank balance is, right? At least I don't think anybody's DVD player did that. It's important to remember that there is a mental scope that every user has about every device that they interact with, every application that they use. And so when they're talking to your DVD player, they're not thinking, hey, I want to order a pizza, or hey, I want to be able to check my bank balance. There are other things, other places that I would go do that. So it's also really important as you think about what intents should I offer to make sure you're only offering things that actually make sense for your user. It's very easy for us to think about, like, I want to do all the things. I want it to be able to do everything we could possibly do in our business. I want them to be able to do it here. But I think your best possible outcome is to start with a few things that users do very frequently, but that are somewhat hard to get to. I often use the Ruby Slippers test from The Wizard of Oz. If it takes them more than 3 clicks in your software to get to the thing that they want, those are the things that they absolutely should be able to do with their voice. If they can open your app and in 1 click or in less than 1 click see the information they need, you're not going to see a lot of usage in a voice interface. But when they can just yell into the air and get something that would have taken them 4 or 5 clicks to get to, yeah, those are the winners. Those are the things you should look at, like, how frequently do those things get used and how can we bubble them up? Okay, architecture diagram. So if you look on the far left side, you can see that I have my little person talking. That's where this whole conversation starts. And they're going to talk to the device that kind of goes up and to the right. They talk to the device, and the way that this all works is the user says a wake word. Most of you, if you have a device at home, probably called Alexa. If you don't know, you can change the wake word on your device to computer or Amazon or Echo. And we added a new one recently that is Ziggy. Yeah, Ziggy, awesome. Somebody knows. So for you guys remember the show Quantum Leap, Ziggy was the voice in the box that they used when they were jumping between times. That is a new wake word. So if you want to change one of your devices to Ziggy, you can certainly do that. But the user says the wake word, and that is the only thing the device can hear. It is not listening for anything else. It's not doing anything else. It's not recording anything else. Those of us that are technically minded often think security and privacy and all those kinds of things. I would not be working on this product if I thought that it was spying on us or listening in a way that it was not very upfront and obvious. So the way that this works, you say the wake word, there is a small onboard engine that can be trained to listen to one word. That's why you have to actively change your wake word and it can't answer to all of them. But you set that wake word engine to listen to one specific word. When the user says that wake word, the device wakes up and it starts recording what the user says. So you'll see a blue ring will happen or a blue stripe depending on the kind of device you have. But a very obvious blue light will appear showing you that, hey, by the way, I'm recording. That recording will happen as long as you speak. And it gets more and more sensitive the longer you speak, so generally people keep it pretty concise. But it captures the audio that you spoke, it takes that audio and it ships it off to the cloud, which you see there in the middle, and then it starts to do some interesting things with that audio. The first thing is it takes that waveform, because that's all we really have at this point is an audio waveform, and it compares it to the language that your device happens to be set up in. So it might be US English, but it could also be German in Germany or English in India, English in India is different than English in the US. English in Canada is different from the English in US. There's different pronunciations. There's different sound libraries, which we often refer to as phonemes. I don't know if you guys have heard that term before. We're getting deep into audio science here. But phonemes are all of the different sounds that are in our words. And so we can match the audio waveform against those library of phonemes for our language and map that basically from speech to text. So now we end up with text, something a computer is far more effective at interacting with and using. So we take that text, and what a lot of people want at this moment, and this is what a lot of chatbots do today, is you just get the text. And now you have to make some decisions about, well, what does this text mean and how does it work? But we've taken that a step further, and we've added a natural language understanding engine on top of all of this. And what the natural language understanding, or NLU, allows you to do is it tries to figure out what it is you actually mean. What was the thing you were trying to accomplish? Coming back to our DVD player, what was your intent? What is the thing that you were trying to do? And so it takes the text and tries to match that as best it can against one of the intents that you've specified inside your application. You can imagine that this is a relatively challenging problem. For any of you that have ever been in a relationship, you know that what you say is not always what you mean, right? How many of you have ever said, "I'm fine," right? We don't actually mean we're fine. We mean leave us alone. I'm mad right now. We'll talk about it later. Those kinds of things can be interpreted by the natural language understanding engine. It's not really good at things like sarcasm. That's one of the hardest problems in speech-based AI. But there are things that it can do to understand things like sentiment analysis. Were they happy or were they sad? Those kinds of pieces can funnel in to help the system understand which intent was really trying to be specified. And then ultimately, that gets mapped to our set of intents, and what we receive as the developer, the person building this application, is a JSON file. Our application, wherever we chose to host it, I thought I had this growing a little bit, but it doesn't look like I do. That gets shipped off to our application, which is the far right side of this diagram. So on the far right side, we have code running somewhere. In most cases, and the default way I'm going to show you today, we just use AWS Lambda. But literally any serverless, any API endpoint that you want to set up on any server anywhere is fine. There's no lock-in, there's no required languages or anything like that. Certain ones are much easier. I'm going to show you using AWS Lambda and JavaScript or Node. But if you want to build it in Java, if you want to build it in Python, if you want to build it in C#, whatever, all of those languages are just as capable of doing this, because at the end of the day, all your piece of the application does is consume some JSON and then send some back. No different than most APIs, right? So that is the entire diagram of how we get to a decision point. Our code has to make a decision about, okay, they said play the movie. I've got to get the movie file, I've got to do the thing, and then I hand a JSON file back with all the information it needs to actually play that thing. We do that in a couple of ways. The first is obviously text to speech. So we have a text-to-speech engine that takes the text that you provide as your application, and it turns it back into Alexa's voice and says it to the user. So literally every time you've talked to any voice assistant, that's how that's working. The application sent some text back. This projector has been doing this all day, so I apologize. It'll come back in just a second. The speech gets turned into that audible audio, the spoken audio that your assistant then speaks back to you. So in each of those cases, that's the speech part that comes back. But there's also a number of other ways that you can interact with your user. One, you may have noticed that a lot of voice assistant devices today have screens on them. Those screens also come as part of that JSON payload. So you can specify what graphics should be on the screen, how things should move, where buttons should be, what interaction models you might have, all of that stuff as well. And then we also have a built-in companion app for Alexa, and it's available on all the phones. And you can get that app, and then inside the app, it'll actually show you information about things that you've requested from your device as well. So if you ask it for directions or you ask it for the weather, you don't have to keep asking it later. You can just pull your phone out and be like, oh yeah, there's the thing I asked for earlier. Maybe it's a sports score or something like that. Okay, so that is the extent of my slides. I don't love to spend a ton of time in slides, but I wanted to just give you guys a quick illustration of kind of how this stuff works. Now I'd love to dive into actually showing you how we make it. Okay. It's not going to do what I want. How do we want to do this? Let's go back to PowerPoint likes to ruin the day. So we just need to mirror our screens. I think that's better. And then there we go. Okay. So this is the Alexa Developer Console. You can get here by going to developer.amazon.com. There are lots and lots of great tutorials on how to get through all this stuff. But what I want you guys to understand is that I'm going to walk you through the pieces that aren't that back-end system. Because wherever we build it, whatever we build, this is fantastic. All we're really building is an application that consumes and sends JSON. We'll spend a little bit of time on that, but what I really want you to understand is how the rest of it is built, the stuff we haven't done before. So the first thing that I'd like to do, is that big enough in the back of the room? Everybody okay? Okay, so I'm going to give this a skill name. I'll call it Devnexus. and I tell it what language my skill can be in, but you can see that I can build in all sorts of different languages and locales. I also have to choose a model. Now, this is one of the first choices you have to make. 99% of the time, if you ever choose to build an Alexa skill, you're going to choose custom. That's where most things live. But there are a bunch of other what we call pre-built models that you can use to handle very specific situations. Flash briefing, if you've ever said good morning to your device, or you've said what's in the news or something like that, it will start reading your flash briefing for you. What this is a whole collection of applications that a user can select, but they're basically news feeds, right? They're short audio kind of experiences that allow a user to say, I want CNN, and then I want ESPN, and then I want the weather, and then I want this, and then I want that. And it just jumps from one to one to one. And you can do that each morning, and the updates are constant. So a flash briefing skill is just one of those. It's a daily briefing of some kind from your news source or whatever media you happen to have. Smart home skill is something that interacts with a device that you are making. So if you don't make hardware devices, this is probably not a thing you need to worry with. But this has a whole bunch of pre-built model stuff like turn the temperature up or down, turn the light on and off. All of that stuff is already pre-built and ready for you. All you have to do is map those individual kind of interactions to your APIs to allow the user to turn their lights on or whatever your device does. Music and video skills are very similar. They allow you to consume music and video. So if you have a video library or a music library legally that you're allowed to share, then you can take those audio files, queue them up, and allow a person to consume your audio or video. Knowledge skills are basically QA skills. They're especially handy in things like businesses and enterprises where there's a whole bunch of common knowledge that people have about where things are or where things live, or like, where's the storage room for this, or whatever. You can have QA skills that allow kind of shared knowledge to grow in one place. And then meetings is kind of a simple way to manage like meeting rooms in your offices. So at Amazon, we have an Echo sitting in every conference table across the entire company. And you can walk into any room and say, hey, when is this room reserved? And it'll tell you. It knows where it is, and it knows what is available. You can also say, hey, can I reserve this room at 2 o'clock, right? Just because you were walking around trying to find a meeting room anyway, it's an easy way to just ask it, like, hey, can you reserve this room for me, and handle it that way. So it handles a lot of that kind of management as well. Anyway, we're choosing custom. I just wanted to let you know what's available there. The last option here is what backend do I want? We also provide completely free hosting for anything that you're building for Alexa. So if you want to use Alexa-hosted Node or Alexa-hosted Python, those are the two options we offer for free, then you can build this. It creates AWS services for you that you do not get charged for at all, but they're obviously only used for your Alexa skill. But as you're building these things and as they start to grow and get popular, some people have some hesitation, like, am I going to end up with an AWS build that's a couple $100s? Like, I want to avoid that. So these Alexa-hosted options are free. There isn't even a way for you to be charged for them, so it's a good safety for that. There are some limitations, and if you exceed limits, which are massively high, you'll get a nice email saying, hey, it's time to move to AWS. You're having a ton of success. Let's talk about how you move. But it's a really great way to get started and what we're going to do today. Provision your own allows you to set up any endpoint anywhere. I mentioned earlier, the only requirements is that you can send and consume JSON and that you're an HTTPS endpoint. That's pretty much it. So as long as you can do that, you can provision your own. Any questions at this point? Yeah, please. I'd love to answer any questions you might have. Okay, perfect. Okay, so I'm going to choose Alexa-hosted Node, but again, I want to remind everybody you can do whatever you want for your backend. This is just the easiest way to get things set up and running. This takes a minute or two once we choose a template. These are all just pre-built templates that you can use, like, oh, I want to see what a storefront looks like. We have a pizza ordering example if you want to play with these. My recommendation generally is if you pick any of these, you're picking them to play. Like, I want to see how that works, or I want to tear it apart and see what I can break and whatever. But when you're building a real thing, I would always choose start from scratch because it does add a lot of extra stuff and NPM modules and all sorts of other things that you may not want. So I'm just going to choose start from scratch, but it's good to know that there are some other examples sitting here. Now it's going to configure all my endpoints and set that stuff up for me. Like I said, it takes about just a minute to get a Lambda function set up. It's setting up an S3 bucket for me to host some files. It's setting up a DynamoDB database for me to manage any kind of user interactions or persistent data or anything like that. So all those things are getting set up right now. In the meantime, we've talked about Devnexus. That's the name we're calling our skill. But we actually need to think about some things that if someone was talking to Devnexus the event, what would they say? This isn't rhetorical, I'm actually curious. Like, what would be some things that people might ask an Alexa skill that is for Devnexus? The schedule, okay? So like what sessions are available at this time, or what time is this session, right? What time does Jeff Blankenburg speak, right? That's cool. Anybody else have any ideas on what we might ask? I know one that's big for me is like, when's lunch? Right? Like, that's always a good one, right? What's that? Yeah, what's for lunch? That's even better. I was here too early yesterday while we're waiting for this, and I walked through the sponsor area downstairs, and they had all these tables out, and they had these giant bowls of mini donuts. Did anybody get any of those? But they were all still covered in saran wrap, and I was like, can I have a couple of donuts? And they're like, no, not till 9 o'clock. And it was like 8:45. And I was like, I got to get back and get a call at 9 o'clock. And he's like, sorry, I guess you're out of luck. So I didn't get any of the donuts, but I hope they were as good as they looked. Okay, so developer console, here we are. This is our first screen. The thing that is the most important, and we're just going to start at the top. I want to walk you guys through all the pieces and parts that happen here, is invocation name. So I mentioned earlier that we need to talk to our Devnexus skill. So when you open a skill, you'll say something like, and I don't think anybody has an Alexa device active here, so we can do this safely. Alexa, open Devnexus, or Alexa, talk to Devnexus, or there's a whole bunch of words we can use to do that. But basically, we have to tell it like, hey, I want to talk to Devnexus. That will open our application and will be that's the only scope of the device at that point. We can't go back and ask it the weather. We can't go ask what time it is or ask to tell me a joke. We are in the scope of Devnexus right now, and when we leave, then we get that whole rich first-party Alexa experience. But when we're in the Devnexus experience, that's the only thing we're talking to. So we have to give it an invocation name. You saw earlier that I typed Devnexus, but that's just kind of the name that'll show up in the store. That's not the name that we actually use. So they have it set up here. They started with change me. You need to change this. You can't publish with the name change me. But I'll call it Devnexus. And I'm doing it purposely as 2 words. I know that they put it as 1 word, and only the D, I think, is capitalized. But when we think about invocation names, are we back? When we think about invocation names, they all have to be lowercase. There can't be any special characters. It has to be easily pronounced. And for all of us, as third-party developers, people that are building things for ourselves, it has to be at least 2 words. And those 2 words can't be copyrighted or trademarked or anything like that. So as much as I wish I could go build the Star Wars skill, it turns out Disney probably has better lawyers than I do. So I can't just go do that, right? But I could go ahead, and I have a skill, actually, that's called the Unofficial Star Wars Databank. And it is a place where you can go ask it about any character or planet or vehicle or weapon or anything, species, and it'll be like, oh, Yoda is this person. Or here, let me tell you about one of the individual planets that I'm blanking, like Baku, is that one of the names? Jakku is what I was thinking of. But it'll be able to answer questions about all of those things for you. So with this one, I'm going to give my skill name Devnexus. This is the thing the user will actually say when they open my skill. And then down here in my interaction model, this is where we start to get into our intents. So you can see there's already some intents defined for me. And these work the same way. If you've ever built a desktop application for Mac or for Windows, these are the default things that you have to have. So think about like a Windows app. You have the Chrome and you have whatever your application does inside the box, but there's a maximize and a minimize button and an X to close the window, right? These are those kinds of things, those default controls that every application has to have. It's kind of the contract between the users. So that is cancel and stop. So you have to have a way to respond to cancel and stop inside your application. You have to have a way to respond to help. A lot of people, I don't recommend it, but a lot of people will use the help intent as a way to, a lot like the about page on your website or in your mobile app. I use this example all the time as like an anti-pattern, but someone will say, like they're in the middle of ordering a pizza in a skill, and they'll say, help, I don't know what to do. And the pizza app skill, whatever, comes up and says, hey, we're a pizza store. We sell breadsticks and pizzas and all sorts of yummy stuff. And it's like, well, that's great, but I needed help with the pizza ordering I was trying to accomplish right now. That didn't help me at all. And so don't use help as about. Use help as contextual help. Understand what the user was trying to do and say things like, hey, it looks like you're trying to order a pizza. You can add toppings by saying this. You can remove toppings by saying this. You can start over by saying start over. Like, give them some clues about what they can say. This is one of the hardest things for me, for sure, but for any developer to remember is that, like, every application you've ever built before today had a user interface that the user could see. And this doesn't have that. There is no visual cues, except if they have a device with a screen, to give them any indication about what they can and can't say. And as you've probably learned, most users are afraid to break something, or they're not sure if they should try, even when it's a visual interface. So when they don't have any idea what they can do, sometimes they'll be very hesitant. And it's good to encourage them to just try and say the things that they want to say in a natural way. Anyway, that's help. I mentioned cancel and help. The bottom two, navigate home and fallback intent. Navigate home is used specifically on devices that have a screen. So you don't have to do anything if you build an audio-only skill. But if you have a screened application where you're putting things on the screens, you need a way for them to be able to navigate home to whatever the home screen is of your app. And the last one is the fallback intent. I mentioned that for each of these intents, and I'll use the hello world as an example. This is a built-in one. This is what we call a custom intent. I'm going to delete this in a second, or at least edit it. But this is the kinds of intents we would build, right? Play, pause, stop, rewind, all those kinds of things. With these kinds of intents, we have to be very specific about what it is we want them to say. So like with hello world, if someone says hello, or how are you, or say hi world, or say hi, all of those examples there's more of them too, I think. Those are representative samples. Remember, this is all machine learning data. So my first instinct, the first time I saw this stuff many, many years ago, was, oh, that's the list of things a user can say. That is not the case. What you are building is a machine learning data set. And so all of these samples are ingested by a machine learning engine, and then it can use that to understand many, many more things that a user could say that look or act or feel like the examples that we've provided. So because of that, because we're going to build a bunch of custom intents that have a bunch of custom utterances or whatever applied to them, that fallback intent that I showed you a second ago, let me go back to that list, this fallback intent here, this one is very specifically for the times that a user says something that are so far out of bounds that it doesn't even come close to matching anything from any of the machine learning samples that you've provided. So this is one of those times where I mentioned we get into the scope of a very specific skill and we live there and we can't do the first-party stuff like play a song or whatever. It's very possible that a user could be in the middle of using your skill and then they're like, what time is my dentist appointment? Which is not a thing your skill does. The fallback intent will be fired instead, and that gives you an opportunity to respond in a very custom way and say, hey, it looks like you're trying to do something that's outside the scope of my skill or whatever. You can give them some feedback and say, my skill does X, Y, and Z. If you're trying to do something else, you might try saying stop or quit first, and then you should be able to do other things on your device. So that is what the fallback intent is designed for, but it's meant to catch those really weird edge cases that are not a good match for any of the intents that you've provided. Okay, so hello world intent. My friend up here said that we should have a schedule intent. So let's do schedule. Now, this is just a naming convention that we've created. It's not necessary. You don't have to call them with the word intent, but it's helpful when you start looking at your JSON and some other stuff like, oh, that's one of the intents. And I'll delete my samples here. We don't really need those. So the first thing I might do is say, what sessions are next? So that might be something that I'd say, and then it would funnel me in and give me something like that. But I might also say, let's see if I can do this. What time is Blankenburg's session? Did the screen just go out again? I thought I just saw it. Yeah. It's a lovely projector. It's doing a great job. Okay, so I added another one, which is what time is Blankenburg's session? Any of you should instantly be having like red flags go off. Wait, I'd have to create like a custom thing for each possible data entry? Like that seems like something I wouldn't want to do. Well, the good news is that we have, it's kind of like a variable, but we call them slots. And so in here, what I can do instead is say, I don't want to have to type Blankenburg session and all of the other speaker names. Like I wouldn't want to put all of that stuff here. That would be kind of tedious. So what I'd like to do instead is I'm going to take this and I'm going to say, I want a new slot. Let's kind of scroll down. I want a new slot called speaker. And in this speaker slot, which I can see down here now, I need to give it a slot type. This is, again, like typing variables in code. But here I have all sorts of different custom options. These are built-in choices that we have. Things like airports. So instead of me having to build a representative sample of all of the airport names, that already exists. If you're looking for someone to give you an airport name, you've already got it. You can just say, hey, I'm looking for a slot value that looks like this. But this list goes on and on and on. There's all sorts of different things, books and authors and cities. And there's some interesting ones, especially with cities, that I think are pretty cool. There's one called US City. And what US City is all the cities in the United States, for the most part, and a sampling of the cities that people that live in the US are aware of. So they might say things like Paris or Sydney or Tokyo or whatever, but they're probably never really going to be mentioning like some tiny village, 100 miles outside of Tokyo. That's probably not a place that they're going to refer to very frequently. And so US City allows you to rely on the knowledge of people that are in the US. In the same way, if you look at the list of like German cities, it's DE_city. That is cities in Germany and cities that German people would be aware of. So especially a lot more of the European cities that are around them would be more obvious and more called out. But these built-in lists, if I find like DE city is right here. You can also see that we have things like DE first name. DE, again, representing German. This is a list of first names you would find in Germany, a list of first names you'd find in the United States, a list of first names you'd find in the UK. So depending on what the context of your skill is or where you expect your users to come from, could affect what your built-in choices are. But I actually don't want one of these built-in choices. What I want is a custom list of all the speakers that are here at the event. So what I'm going to do instead is I'm going to scroll down here to slot types. And I'm going to create a new slot type, and we'll just call it speaker. Actually, I capitalize these. That's my habit. And then we'll put Blankenburg in our list. So I have this slot value Blankenburg. I might also have synonyms for this thing. So maybe they said Jeff Blankenburg, or maybe they just said Jeff, right? I don't know how many other speakers here are named Jeff. I would guess there's probably a couple. But as we think about building out our list, I know there's another guy, a friend of mine, his name's Chris DeMars, spoke here yesterday. So we could add DeMars and Chris. Well, we'll do Chris DeMars here, and then I'll just take this down to DeMars. Okay, so we've got our two slot values, and I'm going to save this, come back to my intents, and now if I come into the schedule intent, I have this speaker slot. It still doesn't have a type, but now I have a new custom slot type named speaker that I can use to apply to this slot type. So what this means is that when someone says something like, what time is Jeff's session, it should be able to create the JSON to represent that to me in code, and that's what I'm going to show you guys next. So in order to get this all work, again, we're building models that have to be ingested by machine learning. I'm going to go ahead and build that. Maybe 30 seconds, 40 seconds while we wait for that to happen. So I have one intent right now called the schedule intent, and I can say what sessions are next, or I could say what time is Jeff's session, and in each of those cases, it will reply slightly differently to me. And I'll show you how we can first see how this stuff works. How many of you are big believers in like continuous integration, unit testing, that kind of stuff? Anybody doing that kind of stuff? So I'm going to show you how we do some of that stuff here. I probably shouldn't use the word continuous integration. I don't think that's fair. But let's at least talk about like how we think about doing unit testing for this kind of stuff. So it looks like we're done. There we go. Perfect. So there's this big blue button here called Evaluate Model. And some of my favorite tools live behind this button. So the first one is an utterance profiler. So I can say, what time is Jeff's session? And what it shows me, and this is just a manual me typing it in, it says, hey, when someone says, what time is Jeff's session, I'm going to hit the schedule intent, and I've recognized that the speaker slot has the word Jeff. So I'm going to hand that off to you and let you know that, in fact, that's the thing that I thought. These are the other things I considered, but these are not the ones that I chose. So it always knew it was going to be a schedule intent, but it wasn't sure which one of those it should actually be. If I change this to what time is Blankenburg session, you can see that now I get the slot Blankenburg that comes through. And there's some more complicated, awesome stuff that I'll show you when I actually show you the JSON here in a second. So this is just manually me coming in and saying, hey, what happens when someone says this, right? But that's kind of tedious. I've got to type at each individual time. So the other thing that I can do is we have NLU evaluation. I mentioned that natural language understanding earlier. This is what allows us to build unit tests to know whether or not things are going to work and whether they're going to continue to work. Because as you might imagine, I built my schedule intent, but then later I might build a speaker intent. And the speaker intent might just give me like the bio or the Twitter handle of an individual speaker that I've requested. Those can potentially conflict with each other because I'm using the same slot. I'm using a lot of the same data. And so as you continue to add intents, it's very possible that you might break something that existed before. And that's where this unit test stuff kind of comes pretty handy. So I'm going to use an annotation set. We'll call this speaker tests. And in here, I'm going to say, what time is Blankenburg session? Okay, so I have this utterance. Now what I need to do is say, okay, what intent do I expect it to hit? Well, I expect it to hit the schedule intent. That's the one that the way I'm thinking about my test, that's what the expected outcome. I would also expect there to be a speaker slot, and the value of that slot should be Blankenburg. Okay, so I have my one utterance. We could build another one that's just, what if I just say DeMars? I don't know what will happen, but let's say I expect these outcomes, speaker and DeMars. Okay, so I've built a couple of tests. I can now save this annotation set, and when we come back to my evaluate model tool, we can see now that I have this nice speaker test annotation source. This is what I use to, I'm going to run tests against that annotation set I just ran. This always takes slightly longer than I want it to, especially because I have a very simple interface at this point. I have just a couple of slots. This is still going to take me like 45 seconds. But what will happen here is it's going to evaluate against each of those cases. It's going to run those tests against my interaction model, the thing that I'm building, all my intents, and it's going to tell me whether or not those things actually passed. I would expect the DeMars one to fail, and something failed, so let's see what happened. So if I open this up, yeah, the DeMars one failed, so it hit the schedule intent, I'm sorry, I was expecting the schedule intent, but it actually hit the fallback intent. It didn't know what to do with that information because I hadn't provided it with any example that's just looking for someone's last name. So it didn't have any of the other values that I was looking for. So we can go back and we can fix that. We can now go back to our intent and say, okay, well, I've got to make that work. So schedule intent, I could just add another thing here that is speaker. And now that I have that, I have to save and build my model again, but that will allow me to make that test pass. Because now I do have an utterance that is just a speaker's last name, right? So this is how we build out our interaction model. And the thing I hate about demonstrating it this way, which is definitely the easiest way, and I think the most visually representative way to show this stuff, is that it's hard to understand that all we're really doing is building a JSON document. And so I want to make sure that I show you that all of that stuff is in here as well. So if I go to the JSON editor, which you can see down here, everything that we've just done, all the changes we made, utterances, all that stuff, all lives right here in this document. So you can see here that I have my invocation name defined right here. Let's see if I can blow it up a little bit. And then scroll up, please. Multiple scroll bars are the worst thing ever. Okay, so you can see I have the cancel intent, help, stop. Then I have my schedule intent. I have defined a slot called speaker that is of type speaker, which will be defined further down the document. I have my samples, which are those samples that we just wrote, right, that have the slots and those things built right into them. I have the navigate home and fallback intent. Now we have our types defined. This is my speaker type, and then you can see that I have two values. I have this one, which is Chris DeMars, and then I have this one for me. That is my entire document. That's what represents my user interface for voice. And this continues to grow and get bigger and bigger as we go. But that's all we're really building is a JSON document. And that's why I say as we move into an IDE like VS Code, if you want to do this all manually, just writing some JSON and formatting it, you can do it all that way. I think this is easier because clicking a button and getting that entire types node to appear and being able to fill that in with just a couple of text boxes is pretty easy. But there are lots and lots of ways to manage this stuff. Okay, so now that we've done that, let's talk about coding. I'm not going to spend a ton of time in here because, again, everybody has different languages and different understandings. I will let you know that you can see this is Node, this is JavaScript. I am bringing in our Alexa Skills Kit SDK. There is a Skills Kit SDK for Node, for Python, and for Java. So if you write in one of those three languages, it's a very convenient, nice way to manage and interact with all of this JSON that's going to be moving around. If it's not, you're going to have to get pretty good at parsing JSON. Because that's ultimately all you're really doing is you're going to receive a JSON document and then you're going to send one back. But for the SDK, it makes it so super easy to handle a lot of the things that we want to do. So I'll use the hello world intent handler is our first example. So first, let's change this. Let's call this schedule intent handler. And down here at the bottom, I'm going to change my registry. So instead of hello world, I'm going to make it schedule. Okay. And then as we look at this, what we can see is that there is going to be a request that comes into our skill. And what we call this an intent request. And it's going to be of type schedule intent, because that's what we created, schedule intent. So the first piece here, in this function, I have one function that is can handle. This is a Boolean function that lets me know whether or not it can act on the data that we've received. So we're going to receive all sorts of different kinds of requests into our skill. When we open the skill for the first time, that's a launch request. When they try to ask about the schedule, that's a schedule intent. Lots and lots of different requests. So what this is doing is saying, hey, if it's an intent request and it's the schedule intent type, then I'm good. I should be the one to act on this. And then if this can handle function is true, then it goes ahead and executes on the handle function. This handle function basically creates the JSON doc using this basic syntax. And there's three pieces here that I really want to explain. So the first one is speak. This speak output you can see is defined up here. It's just going to say hello world. We'll say this is the Devnexus schedule. Now, obviously, we're going to make some logic to make this work, but for now, we can just say this is the Devnexus schedule. And so this speak node right here, this is the one that defines what will actually be said to the user. So you remember the user said something like, what time is Blankenburg session? And then we're going to feed this back. This is our call back to Alexa to say, hey, here's what you should say. This speak node defines what that thing is. So in this case, it would just reply with, this is the Devnexus schedule. There's no other logic or anything in here yet. That's the reply that we'll get. It's this second piece that I think is really interesting, and that I want to make sure you guys understand. So let me do something like, which session did you want? The reprompt is an interesting model, and I like to use this a couple of different ways, but the reprompt at its core is meant to handle the situation where someone doesn't reply. So I want you to imagine, you just sit there, but I'm going to pretend for a moment that I'm talking to you, and I say something to you like, hey, what's the weather outside? And you sit there and stare at me for 5 seconds. I think all of us would agree, in a normal conversation, that's pretty weird and awkward, right? Stop doing it, man. No, I'm just kidding. So I ask him a question, and he doesn't reply to me at all. So what would happen in most cases is I might follow up with additional information or an additional question and say something like, no, actually, like, I've got my suitcase and my backpack. Like, do you think it's going to rain? Because do I need an umbrella? Just to give some more clarifying whatever. But that reprompt, I'm trying again to get him to speak. That's the reprompt. That's what happens here. So in the case that I say, hey, what's the weather outside? And he goes, oh, it's like 70 and gorgeous today. The reprompt doesn't ever come into play. I don't have to reprompt him at all. But if he doesn't reply, if he doesn't say anything, Alexa leaves the microphone open for about 6.5 seconds. And if you don't reply in those 6.5 seconds, then she's going to take what I provided in the reprompt and say that to the user additionally. What session did you want? In the same way that we have human conversations, if he doesn't reply to me again, I'm done. We're going to walk away. This conversation is over. Alexa treats it the same way. I said something to you. I asked you a question. You didn't answer. I replied with a reprompt. You didn't reply to me again. We're done. Alexa closes the microphone, ends your application, and shuts everything down. So that reprompt is the thing that determines how all of that works. If I comment this line out, and I can show you how this works in just a second. If I comment this line out, what will happen is the user will say something, I will reply, and the microphone closes. There is no opportunity to reply as a user. It's only when I provide the reprompt that opportunity to keep the microphone open and continue talking with the user becomes possible. So you are expecting a reply, and as a result of that, you also have to provide a reprompt for when they don't. Those things are combined together. The final line here, get response, that is the thing that actually goes and generates the JSON and sends everything back. So once you've called that function, that's like a return function in any other software that you write, and it is gone, it is sent off, and you're waiting for the next reply to come in once the user says something else. So we have our little schedule thing here. I'm going to go ahead and save my code. I'm going to deploy this. This is actually pushing it out to a real AWS Lambda function somewhere in the world. I think it's all US East 1 for those of you that are familiar with AWS regions. But once that is done, and it is, then I'm going to jump over to our testing tab. And in our testing tab, we have a bunch of other awesome tools. The first thing that I have to do is say, hey, turn testing on. So I'm going to set it for development mode. And the first thing that I want to do is say open Devnexus. Now, if you'll remember, in our code, we had a launch request handler. It was the first one there at the top. I didn't make any edits to that. So it's probably going to say, like, hello, or whatever the hello world sample was.
Welcome. You can say hello or help. Which would you like to try?
Right, that was the statement that we had for the launch request handler. But if I say, what time is Blankenburg session?
This is the Devnexus schedule.
Right, it's recognizing that, hey, we fell into that into the schedule intent, and then it's replying with the speech that we had there in our code. Now, what's interesting in this piece, there's a couple of tools I want to show you, but the first thing that I think is important to see, if I can get all the scroll bars to work, I think I'm zoomed in too far to make that happen, is down here on the left-hand side, this is the actual JSON that was sent to my application. So if I scroll down to the very bottom here, there's a lot of useful information in here. You can see, come on, keep scrolling. You can see that right here, I have my intent request. Remember, that was the first of my 2 Boolean conditions that I was checking to say, hey, can I actually handle this thing? The first one was, is it an intent request? The second was, what kind of intent is it? And that's the schedule intent that you see here. So that schedule intent, it recognized those 2 things were true. The next piece is it said, hey, the speaker value that was provided by the user is Blankenburg. So here's your speaker name, the thing that you need to act on, look up in a database, do whatever with. But then it also has these resolutions. We call this entity resolution because we're resolving out to some kind of entity. And you can see that down here, not only does it give me, the official slot value that I had was Blankenburg, and then remember I had some synonyms for Jeff Blankenburg and Jeff. So even though it heard Blankenburg here, it can also give me the full entity. So let me show you how this changes if I say, what time is Jeff session?
This is the Devnexus schedule.
We hit the same thing, but this time when we look down here at the bottom, you're going to see that the value that it received was Jeff. This is the speaker, this is the thing the user actually said, right? It's representing the words that they used. But if I come down to my entity, I still have that very consistent slot value that I might look up in a database or whatever, because it said, hey, like, they said Jeff, but that matches this slot value. And so I want to make sure you have that whole thing. In addition to that, if we go look at our slot values, there's also a really handy thing built into these. If I come into speaker, I didn't put them in here, but you see I have, the synonyms are here. But we have this optional ID field. If you have a unique identifier in your database already, it makes perfect sense to add that thing here. It gives you a one-to-one match against records in your database. So I could say something like ABC123, and this one is DEF456, right? So it's some kind of unique identifier from my database. In those cases, I'm going to have to wait for this to build again, but in those cases, when I get that entity in that JSON document, it will also have that ID for me. So I don't even care what the words are. Now I can just take that database ID record, whatever it happens to be, go look it up in the database and return those records. That Star Wars database that I talked about, that's exactly how this works. So when they say Han Solo or Scoundrel or whatever they want to say, I can be like, oh, cool, you're asking me about Han Solo. Here's the information I have about him. Because I don't really care what you said. All I want to know is which ID did I match so that I can go get the right record out of the database. While I'm waiting for that to build, and I can jump between tabs here, the other thing that I want to show you, let's do Open Devnexus again.
Welcome. You can say hello or help. Which would you like to try?
I would like to try neither for now. Thank you. Zoom out a little bit. The thing that I want you to see on the other side over here is if I say, I could just say Blankenburg now because we added that other intent.
This is the Devnexus schedule.
Perfect. So on the right-hand side, I've kind of given you a quick tour of what's happening here. There's a bunch of other information about like what size was the screen of the user's device, what are the dimensions. We get that stuff right here. So if we're building interfaces, we know what kind of interface we're looking at. What kind of things does it support? There's also a bunch of unique identifiers, things like the user ID. This is an anonymized, very long string user ID, but it's consistent for that user every single time. So you don't know who the user is, but you know you have this unique identifier every single time. So you can be like, oh, welcome back, or you've been here 12 times, or whatever. And it's not until they choose to give you their contact information or whatever that you can have a more updated record about who that user is. There's also all sorts of account linking stuff you can do. Just imagine OAuth. So like I want to link it to the account they already have in my service or whatever. Very easy to set that stuff up as well. But down here at the bottom, I have that intent request, I have that schedule intent, and I have those slot values that give me the entities. But on the right-hand side here, this is where we actually get to see what the JSON looks like that we sent back. And I wish I could zoom in on this better, but it's just not going to let me do that. But over here on the right-hand side, you can see that it says this is the Devnexus schedule. So we're actually passing speech back to the thing. And so this is my output speech. This is my reprompt. We talked about those two different things. And so in the reprompt, it says, which session did you want? By default, using that reprompt, you can also see this property here, should end session equals false. This means that we should not end the session. We don't want the microphone to close. We want to continue talking to the user. But if you set that to true, that's exactly what will happen. You can set that property. The user will say something. You'll reply, and then you'll just close the mic. That makes a lot of sense for like, tell me a dumb joke. It tells you the joke and closes the microphone. It doesn't wait for you to be like, tell me another joke, because you could just do that automatically. Thank you. So that is, that's kind of the quick tour through all this. There are a couple of other fun things in here that I'd like to show you. The first is if you are building tests and you just want to be like, I need to see how this responds, or you have maybe there's like 7 steps inside your skill to get to a specific thing, you may have samples of this JSON, this left-hand side, the thing that gets sent to your service. You can actually take all of these, and you can use manual JSON, and you can just paste this here and hit send, and it will send it to your endpoint and run it against it. So you don't have to do all the typing and chatting that you saw me doing on the left-hand side. You can just be like, I want to try this kind of thing. And you can have representative JSON files to show, like, I'm already 7 steps in, or I already have some specific data stored or something like that. In addition, and this one's super fun, is that it's just a voice and tone tool. This has nothing to do with your skill specifically, but this allows you to play around and understand how things are pronounced. And so there's lots of different ways to do this, but I'll let this one be a little creepy. I don't know if you guys know this, Alexa can whisper. And so as a result of that, you should try this. If you're at home and you have a device, try making your request while whispering. It will whisper back, which is surprising and sometimes a little creepy, but this is what it sounds like.
I want to tell you a secret. I am not a real human. Can you believe it?
So this markup, though, this Amazon effect where it says whispered, this is called SSML, Speech Synthesis Markup Language, and it allows us to mark up our speech to add all sorts of interesting things inside our content. So it doesn't just have to be talking. We can add audio files, we can add sound effects. There's all sorts of cool things that we can do with this, including manipulating pronunciation. There's a great example. Let me see if I can pull this up quickly. Alexa SSML reference. I type this all the time. There is, if I go to the phonemes section, yeah, here it is. So I'll just take this and then I'll let you guys hear it. But it's, we're in the South. There's 2 ways to pronounce the word pecan, right? And I'm probably saying it wrong. But as we put this in here instead, she will pronounce pecan 2 ways, and then I'll explain how this works.
You say pecan. I say pecan.
Now, what she's actually doing is using this phonetic alphabet called the International Phonetic Alphabet. And this markup right here is telling it precisely how to pronounce a word. And you can use this for everything. And you can see that pecan and pecan this markup is different for each one. So it will actually say the sounds that you provide as part of this phonetic alphabet. And if I come back here and look at this, you can see that we have, for all the different languages and locales, there's a different phonetic alphabet. But you can see like the consonants are pretty obvious, like what does an F or a D or whatever sound like. But when you come down to the vowels, it gets kind of interesting. Like this is the symbol that we use for the A at the end of the word arena, that sound, right? But if we want the A in trap, we use this symbol instead. And so you can start to just piece these symbols together as you sound out a word. Alexa never used to pronounce the word Blankenburg properly. She always put the emphasis in the wrong place, so it was Blankenburg, which just sounded odd. So I could, anytime I was building an application that had to use my name, I could just very easily swap out, wrap that statement in a little phonetic alphabet, and then it would pronounce it right every single time. But we can do that with audio files too. So if I take this one, it's a car accelerating, but this is just we have a whole sound library that you can use for free. And so if I take this and drop it in, right, so you can use any MP3 you want. There's some encoding rules that are pretty simple to fix in like a software like Audacity or something. But literally any audio you want to use, if you have a podcast and you want to feed your entire podcast through it this way, there are ways to do those kinds of things. But this is really great for little sound effects and things like that. So I have only a couple of minutes left. The last thing I'd like to show you, I thought I had it open, is an application that I'm working on right now, which is I'm trying to build an entire voice-based casino. So right now I'm only building the slots engine part of it, but in here I have a bunch of sound effects and things. So what I wanted to show you is that first, you can see that I have all of the files and things that I would have in other places. Let me blow it up a little for you. So if I come down here into my interaction model and look at this, you can see that I have the same thing, right? This is that same JSON document, but this is a little more complicated. I have slots, I have wager amounts, I have those kinds of things built in here. The other thing that I can do is I can use the local debugging function built into VS Code. So I can say, hey, let's start up the debugger. And you can see down here that it's actually started a debugging session for me. So I can set breakpoints. I'm running my code all here locally. But now what I'm going to do is jump back to my browser somewhere. And let's go back to my skills, because I have this skill just one down here. I'm actually working on this actively. And we'll come into that testing tab. And let's say, open casino slots.
Welcome to the Chatsino. You currently have 100 coins available. What would you like to do?
Right, you can see how the responses just change a little bit when you add sound effects, and I added some excitement to her when she said, welcome to the Chatsino. Like I actually added an emotion tag around the speech so that she sounds like she's standing on her toes and she's like excited to say the things to you, right? If I say bet 5, this is broken right now, but you'll get to hear the sound of the reels on the slot machine turning, but the part I have where it actually like chunks, where each wheel stops, I'm in the middle of working on that, so it's not going to work right now. You'll just hear the reels spinning. But if I say bet 5...
There was a problem with the requested skills response.
Never mind. Like I said, it's in the middle of being worked on. So, but let me show you how what's actually happening behind the scenes here. All of this blue, this is the payload. This is that JSON that we saw in the testing tool. This is the payload that's actually coming into my application. I can see that down here at the bottom, I had the launch request come in. Then I'm doing some other stuff, so I had to get my user record. I had to see how many coins they have. We went through all of that, and then down here at the bottom, this was my second request. And I came in here, and it saw that it was an intent request. It saw that it was the wager intent. It saw that they were wagering 5 coins. And then it went to go do something, and I have to figure out what's broken. But it's logging all of my errors and everything else that happened in here as we move through this. So this is a way for me to set breakpoints in my app, be able to see exactly what's going on, and have a really rich debugging experience where the browser doesn't necessarily give you all of that. But I've spent an hour talking to all of you. I'd love to we got a couple minutes left, and we can run a little long, I think. What questions do you guys have for me? Yeah, now's the time.
So you used the word Java during this talk?
I did.
And but I didn't see it in the Java option. Does that mean that it costs?
No. Well, I mean, yes and no. Go ahead.
I remember when Alexa skills first became available to write, using Java was much more complicated than using JavaScript. And I don't know if that's still true.
It is still true, although because you can run Java as a runtime in AWS Lambda, it's not as hard as it used to be. But you are building a Java application in a serverless environment like Lambda or wherever else you want. But it's not necessarily more complicated, but it's more complicated in that Java is a more complicated language that requires compilation versus interpretation in a scripting language, but that's really about it. The reason you didn't see it as an option is because the free options we offer are just Node and Python. But when you build things, I'm going to use AWS as the example because that's the thing I'm most familiar with. The free tier limits on AWS Lambda are about I think it's 1 million invocations a month. So that means that your Lambda function can hit 1 million times a month before you incur a single penny. And I think the second million only cost you about $5. If any of you, and I encourage all of you to go build a skill and take me up on this challenge, if any of you have a month in which you have more than 1 million invocations of your skill, I will fly to whatever city you live in and buy you a steak dinner because that is an incredible accomplishment. It's really, I mean, it's not impossible, but it's an incredible accomplishment. So the opportunity to have a lot of cost is pretty low, but it's not zero. Yeah. Yeah. So it does a couple of things. So what it'll do is it'll return the one it thinks is the best match. But you remember how I showed you the entity resolution? It was showing me, like, I typed Jeff, but it still returned Blankenburg to me. It will actually return all of the matches for you. So what I do in my applications, especially that Star Wars database, where someone might say Skywalker, there's a couple characters with that last name, I can see, like, oh, there's 3 elements in that object, or in that array. I want to be able to, I'm not going to just reply with the first one. What I'm going to do instead is say, hey, you said Skywalker. Did you mean Anakin or Shmi or Luke or Leia? Like, who did you mean, right? Hopefully no spoilers for anybody. So like, I can use that array as a determination about whether or not they match something perfectly or whether I need to disambiguate and say, like, ask them again. So you have that information at your disposal, yeah. Yeah. Yeah, again, the backend really doesn't matter. There isn't a TypeScript SDK, but you could use the Node SDK and import that into into your TypeScript app. But yeah, what you build the backend on really doesn't matter. It's just about producing that JSON document. So if you want the luxury of the SDK, which I showed you, which saves you a ton of time, then yeah, you're going to be Node, Python, or TypeScript. There is a great open source C# library out there. We also have a Java SDK. But outside of that, if you, like, we were talking about Kotlin in the previous session, there isn't a Kotlin SDK. So if you are a Kotlin developer and that's what you want to be, that's fine. But you're going to be receiving a JSON document. You're going to have to parse it, understand what you need and where it needs to go, and then you're going to have to create a new one on the way out. But it's just harder, but you can definitely do it anywhere. No. The only languages that we support from an SDK perspective are Node, Python, and Java. Yeah. Mm-hmm. Yeah. No, there's the question was, can I extend or shrink the amount of time that the device waits to listen? It will continue listening if you keep talking. So if you don't start talking till the 5th second, but then you talk for 5 seconds, that's fine. It'll handle that. But if you don't talk for 6 straight seconds, then it's going to be like, oh, you're not communicating with me. There is not a way to extend that window, primarily for security reasons. It would be very easy for someone to build an application that says, just leave the microphone open for 3 hours, right? And then you get to respond to the next thing that's said in the house, which is not ideal for customers, right? Like, they want to be able to trust these devices. So no, there is not a way to do that today. They are working on a thing, we announced this last summer, that will allow you to basically have a short or a long. So let's say it's 6 seconds or 12 seconds, but you don't get to specify the time. That's awesome. You don't get to specify the time, you just get to specify whether you want the short window or the long window. And that's not possible yet today, but it should be soon. Yeah. Yeah. Well, here's the awesome news. If I went home and I talked to one of my devices in my house right now, and I said, open Devnexus, it would work. So, because my devices are set up on the same account that I'm doing all of this stuff in. So especially if you're building for yourself, we've already done it. We've done all the work necessary to get it on my own devices. If you want it on someone else's devices, there's a couple of ways. We offer a really robust beta program. It runs for 90 days. You can have 5,000 people. It handles invites and all that kind of stuff for you. But it is rigid in that it only runs for 90 days. It's not a way to get it on everybody else's devices forever. And when that 90-day window expires, you would have to re-invite them. They would have to click a link and add it again. But We offer a service called Alexa for Business. If you're thinking about deploying a skill to a bunch of devices inside your company, you can use Alexa for Business to basically whitelist a set of devices and make that skill available only on those individual devices. But what I just did here is a perfect example of how I have like a dozen skills I use in my house only for us. My colleague has a chicken coop at his house in Phoenix where you can imagine it gets hot. And so he has some fans and a temperature sensor inside the chicken coop, and he can ask any time, like, what's the temperature in the chicken coop? It's supposed to turn on automatically, but he built a custom skill just for the devices that are in his chicken coop. That doesn't make any sense to make it available to the world. So all he had to do was build it, and it's available instantly. Yeah. Yeah.
I have a particular skill that I really like using, but it has two problems. One of them is very peculiar that it often does not understand the utterances that it's supposed to understand, and it says it's understanding.
Okay.
And I can't imagine where in the chain of events that happen here that would be a problem for a particular app or for a particular skill.
Yeah, I mean, there's a number of reasons. There's a number of possible failure points in the scenario that you're describing. It could be that the Alexa speech-to-text engine is having some challenges interpreting what you said. I find often, and I'm not suggesting this is your case, but I find often if people have a relatively thick accent, or if they have any kind of speech impairment, Alexa can oftentimes have trouble understanding. There are tools that we've created. Alexa is very focused on accessibility. There are tools that we've created that do voice training, so that if you have a heavy accent that she's not understanding, you can go through some simple voice training. You read like 4 sentences to a device, and it's like, oh, cool, I understand you now, and then it just works. There was a running back for the Seattle Seahawks who does not have any speech impairments of any kind, but he could not say Alexa. Every time he had a store, he wanted devices in the stores to like do things, and we're like, all right, why don't you try it? Say Alexa, open your thing, and it was always Alexis, always. He couldn't even hear the difference, and so we had him go through the voice training, and all of a sudden it's like, oh, I understand everything this guy's saying now. It was perfect. So those kinds of things might be necessary, but if it's your voice and you're not, normally it works, and sometimes it doesn't.
And it's this one particular app. That's what
Yeah.
I don't understand.
That's very odd. I mean, I'd be happy to chat with you after about what that is, and we can dig into it a little bit. But yeah, I'm not sure exactly on why that one happened. Anybody else? I don't want to keep you guys from lunch, which I still don't know what lunch is. Maybe our skill should know. All right. Well, thank you guys so much.